Hello guys, welcome to another video here on SQL Injection, and this is under the Web Fundamental learning part here on Tryhackme. We're currently treating the introduction to web hacking module, and this is the last room here, which is the SQL Injection. Without further ado, let's jump right into it. Now in this room, we're going to learn how to detect and exploit SQL Injection vulnerabilities. And task 1, brief. SQL. This is structured query language. The SQL injection, mostly referred to as the SQLi, is an attack on web application database server that causes malicious queries to be executed. When a web application communicates with a database using input from a user that hasn't been properly validated, they run the potential of an attacker being able to steal, delete, or alter private and customer data, and also attack the web application authentication methods to private customers areas. Now this is why SQLi is one of the most oldest web application vulnerabilities, and it can also be the most damaging. In this room, you'll learn what databases are and what SQL is with some basic SQL commands, how to detect SQL vulnerabilities, how to exploit SQLi vulnerabilities, and as a developer, how you can protect yourself against SQL injection. Answer the question below. What does SQL stand for? It stands for structured query. That's language. Hit enter, and that's correct. Let's head on to task 2. What is a database? If you're not used to working with databases or exploiting them, there's probably some new terminologies or terminology to get used to. So let's start with some basics on how databases are structured and how they work. Now, what is a database? A database is a way of electronically storing collections of data in an organized manner. A database is controlled by a DBMS, which is an acronym for Database Management System. DBMS fall into two camps: relational and non-relational databases. So the focuses of this room will be on relational databases. Some common ones you would come across are MySQL, Microsoft SQL Server, Access, Postgres SQL, and SQLite. We'll explain the difference between relational and non-relational database at the end of this task, but first it is important to learn a few terms. With the DBMS, you can have multiple databases, each containing its own set of related data. For example, you may have a database called shop. Within this database, you want to store information about products available to purchase, users who have signed up to your online shop, and information about the orders you've received. You store this information separately in the database using something called tables. Now, the tables are identified with a unique name for each one. You can see the structure in the diagram below, but you can also see how a business might have other separate databases to store staff information or the accounts team. Now, in a database, we can have an information on a table called shop. We can also have information about the staff working in that shop or in that company, and then we can have accounts related to either the customers, the staffs, and other things. Okay, so what are tables? Now, a table is made up of columns and rows. A useful way to imagine a table is like a grid with the columns going across the top from left to right, containing the name of the cells, and the rows containing the name of the cell, and the rows going from top to bottom, with each one having the actual data. Okay, so as you can see in the picture, columns would be more like at the top from left to right, the ID, the username, the password. These are the columns, while the rows is actually what's containing the data. Row 1 would have the data of John, or one of the ID 1 with the username and the actual password, and so on. Columns. Each column, better referred to as field, has a unique name per table. When creating a column, you also set the type of data it will contain. Common ones being integers, numbers, strings, standard text, or dates. Some databases can contain much more complex data such as geospatial, which contains location information. Setting the data type also ensures that incorrect information isn't stored, such as string hello world being stored in a column meant for dates. Now, if this happens, the database server will usually produce an error message. A column containing an integer can also have an auto increment feature enabled. This gives each row of data a unique number that grows incrementally. Now, with each subsequent row, doing so creates what is called a key field. A key field has to be unique for every row of data, which can be used to find the exact role in SQL queries. Rows. Rows of records contain individual lines of data. When you add data to the table, a new row of data is created. When you delete a data, a row or record is removed. Now, let's finally get to what's the difference between a relational versus non-relational database. A relational database stores information in tables, and often the tables share information between each other. Now, they use columns to specify and define the data being stored, and rows actually to store the data, just like we saw. Now, the tables will often contain a column that has a unique ID, which is the primary key, which will be used in other tables to reference it and cause a relationship between these tables, hence the name relational database. Non-relational database, sometimes called NoSQL, on the other hand, are any sort of database that doesn't use tables, so they reverse columns and rows to store their data. They don't use columns and rows to store your data, so a specific database layout doesn't need to be constructed, so each row of data can contain different information, giving more flexibility over a relational database. Some popular databases of these types are MongoDB, Cassandra, Elasticsearch, and so on. Now that you've learned what a database is, let's learn how we can actually talk to it using SQL. Let's answer the question below. What's the acronym for the software that controls a database? The software name is the DBMS, Database Management System. Okay, so we have DBMS. Enter. Correct. Now, what is the name of the grid-like structure which holds the table, which holds the data? I already said the answer, so it's table. Hit enter, and that's correct. Let's head on to task 3. Let's get into the nitty-gritty. What is SQL? SQL, which is the structured query language, is a feature-rich language used for querying databases. These SQL queries are better referred to as statements. Okay, the simplest of the commands which we'll cover in the task is used to retrieve, which is to select, update, insert, and delete data. Although somewhat similar, some database servers have their own syntax and slight changes to how things work. All of these examples are based on my SQL database. After learning these lessons, you will easily be able to search for alternative syntax online for the different servers. It's worth noting that SQL syntax is not case sensitive. Select, we're looking at the select statement or the select tool. The first query type we'll learn is the select query used to retrieve data from the database. Now, select asterisk from users. This is basically telling you to select everything from the table called users. Now, the first word select tells the database we want to retrieve some data. Now, the asterisk tells the database we want to receive back all columns from the table. All columns, remember all columns, or the ID or the usernames or the passwords, right? For example, the table may contain 3 columns: ID, username, and password. From users, tell the database we want to retrieve data from the table named users. Finally, the semicolon, I forgot to mention that at the point. Okay. Finally, the semicolon at the end of this particular statement tell the database that this is the end of the query. Now, the next query is similar to the above, but this time, instead of using the asterisk to return all columns to the database, we want to specify some things. We are just requesting the username and the password field. Now, select username. Remember, we had 3 columns before, so you're specifying some columns now. So select username, comma, password from users, and then semicolon to end the query. Now this will bring out everything from the table except ID, alright, the ID column. Now the following query, like the first, returns all the columns by using the asterisk selector, and then limit 1 clause forces the database to return only one row of data. Changing the query to limit 1, 1 forces the query to skip the first result, and then limit 2, 1 skips the first 2 results, and so on. You need to remember the first number tells the database how many results you wish to skip, and the second one tells the database how many rows to return. So if I use limit 2, 2, it will skip the first 2 results or the first 2 rows and produce the third and the fourth, because I just need only 2, right? So that's basically it. Now lastly, we're going to utilize the where clause. This is how we can finally pick out the exact data we require by returning data that matches our specific clause. Now we're going to select asterisk, which is everything from users table where username is admin. This will go into the users table and look for only where there's an admin in the role, or the username is equals to admin, the role where the username is equals to admin, basically. Now this will only return rows where the username is equals to admin. Now select asterisk, or select everything or every column from users where username is not admin. So it's going to return every table, every row except the row where the username is equals to admin. Alright. Okay, now select asterisk from users where username is equals to admin or username equals to join. So it will go into that table, look for where username is equals to admin, produce that. Or it will also, if there's no admin, it will also look for a username where it's John. So basically all statements is basically returning both. Now but in this case, it's if there's no admin in this table, you definitely see John, and if there's no John here and there's admin, you definitely see admin, because this will only return the rows where the username is either equal to admin or John. Now select asterisk from users where username is equals to admin and password equals to password. This is basically, this is more or less what we're going to see later on how password forms work, but it's basically going to make sure that in that row the admin is, the username is admin and the password is password, hence this. So if the username is admin and the password is not password, it will not return any row if there's no matching admin and password role in that particular table. Okay, and using the like clause allows you to specify data that isn't an exact match, but instead either starts, contains, or ends with certain characters by using where to place the wildcard character represented by the percentage sign, right? Now select asterisk from the users where username like, all in quotes, a percentage, then end of query. What this does is it's going to go into the users table and look for where username starts with a. Username starts with a, in this case admin. This returns any rows with the username beginning with the letter A. Now select asterisk from users where username like, in quotes, percentage n. This will return only results where the username ends with n. Okay, and then this is the end of the query. Okay, select asterisk from users where username like, all in quotes, percentage mi, percentage sign, and then end of quotes. This is going to select the rows in these tables where there is mi, like mi, in the middle of the username. So in this case, admin. So more or less, this returned any rows with the user's name containing the character mi within them. Union. The union statement combines the result of 2 or more select statements to retrieve data from either single or multiple tables. Now, the rules to this query are that the union statement must retrieve the same number of columns in each select statement. Now, the column have to be of a similar data type and the column order has to be the same. Okay, similar data type, same column order. Now, this might sound not very clear, so let's see the following analogy. Say a company wants to create a list of addresses from all customers and suppliers to post a new catalog. We have one table called customers with the following content, ID, name, addresses, city, postcode. This is for the customer. Right now, the second table called suppliers with the following content: company, address, city, postcode. So we see similarities here in the column order. And now, using the following SQL statement, we can gather the results from the two tables and putting them into one result set. So we have select name, address, city, postcode from customers, union select company address, city, postcode from suppliers, and this is what will happen. So usually the first one we have will be on the top where you see this data here is the data of the customer, and union select it to combine it with the information from the suppliers table, which is the company, the address, city, and postcode. Okay. Insert. The insert statement tells the database we wish to insert a new row of data into the table. Now, into users tells the database which table we wish to insert the data. So we're looking at this particular query here, insert into users. So the into users tells the database which table we wish to insert this data. Then username, password provides the column we are providing data for, and then the values Bob and password would provide the data, the actual value or the data that we need for the previously specified column. It will insert the username and password into this table. So we'll have a new username Bob and we'll have a password 123. Update. The update statement tells the database we wish to update one or more rows of data within a table. You specify the table you wish to update using we're looking at this statement here. So update all right, update percentage table name percentage set, and they select and then select the field or fields you wish to update as a comma separated list, such as username equals to in quotes root and password in quotes password. Then finally, similar to select statement, you can specify exactly which row to update using the where clause, such as where username is equals to admin. So if you're looking at this query, you'll say update the users table where we want to set the username. Anywhere you see a username, where we want to set username as root, password as pass123, but where the username is equals to admin. So it's going to go into that table and look for where the username is admin, and then to change that username to root, and of course the password belonging to it as pass123. Now delete. The delete statement tells the database we wish to delete one or more rows of data. Apart from missing the columns you wish to return, the format of this query is very similar to select. You can specify precisely which data to delete using the where clause and the number of rows to delete using the limit clause. So delete from users where username is Martins, and so it will just clear that out. Delete from users is basically going to clear everything because no where clause was being used in the query. All the data will be deleted from the table. Now let's answer some questions and head on to task 4. What SQL statement is used to retrieve data? So we're looking at select. Alright, what SQL clause can be used to retrieve data from multiple tables? We're looking at union, multiple tables, union. And finally, what SQL statement is used to add data? We're looking at insert. Hit enter. Perfect. Let's go to task 4. What is SQL injection? Now, the point wherein a web application using SQL can turn into SQL injection is when user provided data gets included in the SQL query. What does it look like? Take the following scenario where you come across an online blog, and each blog entry has a unique ID number. Now, the blog entries may be either set to public or private, depending on whether they are ready for public release. Now, the URL for each blog entry may look something like this. So we have https website.thm blog id equals to 1. From the URL above, you can see that the blog entry selected comes from the ID parameter in the query string. Now, the web application needs to retrieve the article from the database and may use an SQL statement that looks something like the following. So we have select asterisk everything from blog where ID equals to 1 and private equals to 0, limit 1. Okay, now from what you've learned in the previous task, you should be able to work out that the SQL statement above is looking in the blog table for an article with an ID number of 1 and the private column set to 0, which means it's able to be viewed by the public and limits the results to only one match. Now, as was mentioned at the start of this task, SQL injection is introduced when user input is introduced into the database query. In this instance, the ID parameter from the query string is used directly in the SQL query. Now, let's pretend article ID 2 is locked as private, so it cannot be viewed on the website. We can now instead call the URL the https website.thm blog ID equals to 2, place the query string, and then comment, which would then in turn produce the SQL statement that looks like select everything from blog where ID equals to 2 and private equals to 0 limits 1. This comments it out. Now the semicolon in the URL signifies the end of the SQL statement, and the 2 dashes causes everything afterwards to be treated as a comment. By doing this, you're just in fact running the query. Hence, you're now going to be like select everything from blog where ID equals to 2. Hence, pulling up the ID equals to 2. That is meant to be private. Now, so this will now return the article with an ID of 2, whether it's set to public or not. This was just one example of an SQL injection vulnerability of a type called in-band SQL injection. There are 3 types in total: in-band, blind, and out of band, which we will discuss over the following tasks. Now, what character signifies the end of the SQL query? That should be the semicolon, right? Hit enter. Correct. Now let's head on to task 5, the in-band SQL. We're going to start this machine. We're going to be needing that. Now let's continue. In-band SQL injection. Now, in-band SQL injection is the easiest type to detect and exploit. In-band just refers to the same method of communication being used to exploit the vulnerability and also receive the results. For example, discovering an SQL injection vulnerability on a website page and then being able to extract data from the database to the same page, so getting the results right in your home page. Okay, now error-based SQL injection. This type of SQL injection is the most useful for easily obtaining information about the database structure, as error messages from the database are printed directly to the browser screen. This can often be used to enumerate a whole database. Union-based SQL injection. This type of injection utilizes the SQL union operator alongside a select statement to return additional results to the page. This method is the most common way of extracting large amounts of data via an SQL injection vulnerability. Practical. Click the green Start Machine button to use the SQL injection example practice lab. We've done that. Now each level contains a mock browser and also SQL query and error boxes to assist in getting your queries or payloads correct. Level 1 of the practice lab contains a mock browser and website featuring a blog with different articles which can be accessed by changing the ID number in the query string. Now let's head up to the top here and click show split screen. This will be ready in a couple of seconds, and let's continue. Under the practical, we're going to start with level 1. Please note that I have tried to, there's some, if you notice, this is supposed to be a font color white, or should I say the color is meant to be white, but looks like Tryhackme just recently updated their system and haven't taken note of this, because I have actually switched my system here to color theme white. It still doesn't affect this, otherwise here would have been dark as well. So you're going to bear with me. I'm going to try as much as possible to highlight the results here, especially from the top here where we see level 1 error-based SQL and so on and so forth. Okay, please try and bear with me. All right, let's get on to it now. The key to discovering error-based SQL injection is to break the code's SQL query by trying certain characters until an error is produced. Now, these are most commonly single apostrophes or a quotation mark. So try typing an apostrophe, after the ID equals to 1 and press enter, and you see this returns an SQL error message. Let's see. Previously, if this is the URL http website thm article ID equals to 1, if I hit enter, we'll get this result where you see my first article ID equals to 1. Hi and welcome to my very first article for my new website. So if I put an apostrophe right there, okay, and hit enter, we get an error message. Okay, we get an error message, right? This error message is informing us of an error in our syntax. The fact that you've received this error message confirms the existence of an SQL injection vulnerability. We now exploit this vulnerability and see the error message to learn more about the database structure. Now, the first thing we need to do is to return data to the browser without displaying an error message. Firstly, we'll try the union operator so we can receive results if we choose it. Try setting the mock browser ID to 1 union select 1. Now, what this means is it's going to be ID equals to 1. After that, we now have a union select 1. Hit enter, and let me highlight this. Okay, the statement should produce an error message just like we see now, informing you that the union select statement has a different number of columns than the original select query. So let's try again by adding one more column. So we're going to add another column, comma 2. Right, hit enter, and we still have the same error. So we're going to add one more column. We keep trying that, more or less try an error. Hit 3, enter, and looks like we got something here. So now, success, the error message has gone and the article is being displayed, but now we want to display our data instead of the article. The article is displayed because it takes the first returned result somewhere in the website code and shows that. So to get around that, we need the first query to produce no result. This can simply be done by changing the article ID from 1 to 0. So instead of unit ID equals to 1 union select 1 to 3, we're going to use ID equals to 0, and then we're going to hit enter, and let's see what happens. So we'll now see that the article is just made up of results from the union select, returning the column value is supposed to be of 1, 2, and 3. We can start using these results. You see that the first column result was 2, the second result column was the ID equals to 1, and the third is the 3. Alright, now we can start using these returned values to retrieve more useful information. First, we'll get the database name that we have access to. To do this, we're going to use the same query strings where ID equals to 0, union select 1, 2, but instead of 3, we're going to use what we call database. We're going to type in the database, and we're going to put that in brackets. Okay, hit enter, and let's see what comes up. So we see we got the same result, but instead of 3, we now have the name of the SQL, the name of the database, which is now the SQL1. Our next query would gather a list of tables that are in the database, and to do this, we have to use what we call a group concat. Okay, alright, this method gets specified column, in our case table name, and from multiple return rows, and puts it into one string separated by commas. So instead of like table, usually is in tables, but this particular method will retrieve all these solutions and put them in in one string separated by commas. The next thing is the information schema database. Every user of the database has access to this, and it contains information about all the database and tables the user has access to. Now, in this particular query, we're interested in listing all the tables in SQLi1 database, which is article and staff users, right? Okay, now at the first level aims to discover Martin's password, which is actually the question we meant to answer here, which is what is the user's Martin's password, right? Now the staff users table is what interests us, so we can utilize information schema database again to find the structure of this table using the below query. Now first, we're going to use this and see what will pull up. this particular code, let's post from id equals to 0, hit enter. Okay, once we've done that, look at what we get. So we now get the article and staff user results as what we try to pull up the tables under this particular SQLi one. Okay, now the next thing we want to see is we want to pull up the columns, right? Columns. So we're going to use this query statement. We'll have group concat column name from information schema dot columns. All right, where table name is equals to staff users, because we're looking for password. We want to go into the staff users. We're not looking at article anymore. So we'll copy that, and then from, let me delete this, and from id equals to 0 here, Ctrl V, hit enter, and here we go. Okay, there's an error. What did I do wrong? Okay, I think I see it. I didn't close something here. Close that with the quotation, hit enter. Okay, perfect. So we now get a result from the table staff users. It contains 3 columns: id, password, and username, right? It contains id, password, and username. Now the query result provide 3 columns from the staff. Like we know, we can now use the username and password columns for our following query to retrieve the user's information. So I'm going to copy this, and it's going to pull up our again. We use the group concat method to return all the rows into one string and make it easier to read. We also add the in quotes column to split the username and password from each other, and then instead of being separated by commas, we'll now we've chosen the HTML left arrow br right arrow tag that forces each result to be on a separate line to make for easier reading. Okay, so we're going to use that now. Let's see if we can pull up the results for that particular users. So I'll paste this, and I'm going to hit enter, and let's see. Voila! So we have all the usernames and password all pulled out right here. Okay, so this code was to enable us get that, and from here we can see that Martin's password is password. So I'm gonna see. Okay, from here. This is really frustrating, but I'm just going to manage. So we'll come over here to answer the question for this particular level 1, and paste that password, hit check password, and that was correct. And to notice that we have level 2 blind SQL, and then we have a flag here. Okay, you should have now access to Martin's password to enter to move to the next level. What is the flag after completing level 1? Paste this here, submit, and voila. Let's head on to task 6. Task 6 is still under blind SQLi authentication bypass. Okay, now the blind SQLi, unlike inbound SQL injection, where we can see the results of our attack directly on the screen, blind SQLi is when we get little to no feedback to confirm whether our injected queries were in fact successful or not. Now this is because the error messages have been disabled, but the injection still works regardless. It might surprise you that all we need is that little bit of feedback to successfully enumerate a whole database. Authentication bypass. One of the most straightforward blind SQL injection techniques is when bypassing authentication methods such as a login forms. Now, in this instance, we aren't that interested in retrieving data from the database. We just want to get past the login page. Okay. Now, login forms that are connected to the database of users are often developed in such a way that the web application isn't interested in the content of the username and the password, but more in whether the two make a matching pair in the user's table. In basic terms, the web application is asking the database, do you have a user with the username Bob and the password Bob123? Now the database replies with either yes or no, true or false, 1 or 0, and depending on that answer detects whether the web application lets you proceed or not. Now, taking the above information into account, it's unnecessary to enumerate a valid username and password pair. We just need to create a database query that replies with a yes or true or 1. Now, practical. Level 2 of the SQL injection example shows the exact example. Now, we can see in the box labeled SQL query first. This is the login form. This is what we see here. And let me hit this enter. If we done that. Let me see here. This is more like the SQL query. The SQL query here, we're going to see more about that here, and the SQL result. So let's go on. This is the query. So it's going to select everything from users where username is equals to the username you want, and the password limit 1. This is what works for it. Note that the username all in between the percentage signs and password values are taken from the login form fields. Now the initial values in the SQL query box will be blank as these fields are currently empty. Now to make this into a query that always returns as true, we can enter the following into the password, which the password field. We used a quotation or 1 equals to 1, which turns the SQL query into select everything from users where username is this and password is empty, or 1 equals to 1. Because 1 equals to 1 is a true statement and we've used an OR operator, this will always cause the query to return as true, which satisfies the web application logic that the database found a valid username and password combination and that access should be allowed. So we'll come over here where we have this login, and then I'm going to use this, not that. I'm going to come into password area here, use this quotation mark, and I'm going to type in or 1 equals to 1 and then a semicolon. Hit enter. Login. Voila, as you can see, we entered into what happened. You bypass the login and can now move to the next level. Okay, so let's see what the SQL query looks like. So this is what the SQL query looks like. Username or 1 equals to 1 limit 1. So I'm going to hit level 3, and here is level 3 Boolean based blind SQL, and this is our code. Let's copy that and we'll use that to answer this question here. What is the flag after completing level 2? I'm moving to level 3, submit, and voila, there we go. So let's head on to task 7, Boolean based SQL. Boolean based. Now, Boolean based SQL injection refers to the response we receive from our injection attempts, which could be a true or false, yes or no, on or off, 1 or 0, or any response that can only have 2 outcomes. Now, that outcome confirms that our SQL injection payload was either successful or not. On the first inspection, you may feel like this limited response can't provide much information. Still, with just 2 responses, it's possible to enumerate a whole database structure and contents. Now, practical. On level 3 of the SQL injection example machines, you are presented with a mock browser with the following URL, which is the https website.thm check user query string username equals to admin. Okay, now this is it. If you hit enter, we're going to see a result here that says taken true, right? Okay, now the browser body contains taken true. This API endpoint replicates a common feature found on many sign-up forms, which checks whether a username has already been registered to prompt the user to choose a different username. Because the taken value is set to true, we can assume the username admin is already registered. Now we can confirm this by checking the username in the mock browser address bar from admin to admin123, and upon pressing enter you see the taken value has now changed to false. So I'm going to put admin123 over here, and then I'm going to hit enter, and I'm going to check the endpoint result here. It says taken equals to false. Now the SQL query that is processed looks like the following. It looks like select everything from users where username is equals to that particular username limit 1, right? Now the only input we have control over is the username in the query string, and we will have to use this to perform our SQL injection. Keeping the username as admin123, we can now start appending to this to try to make the database confirm true things, changing the state of the taken field from false to true. Now, like in previous levels, our first task is to establish the number of columns in the username table, in the users table, which can be achieved by using the union statement. Change the username value into the following. So admin123 union select 1 dash dash, Now, as the web application has responded with the value taken as false, well, I'm going to copy this, and I just need to copy this. Yes, once I copy this now and paste that here, let me see, paste that here, hit enter. Let's see, we still have false, right? As the web application has responded with the value taken as false, we can confirm this is the incorrect value of the columns. Keep on adding more columns until we have taken value of true. You can confirm that the answer is 3 columns by setting the username to the below value. So if we set this comma 2, hit enter, we will get false. And if we set this comma 3, hit enter, we'll get true. Okay, so this answer is it. Now that our number of columns has been established, we can work on the enumeration of the database. Our first task is to discover, let's see what we're looking for, the correct username and password to go into this. Right now, method, okay, we can do this by using a built-in database method and then use the like operators to try and find results that will return a true status. Try the below username value and see what happens. So we try this, we get a true response because in the like operator we have the value, the percentage, which will match anything as it's a wide value. If we change the wildcard operator a percentage, you will see the response goes back to false, which confirms that the database name does not begin with a letter A. We can cycle through all these letters, number and characters such as and until we discover a match. If you send the following as the username value, you receive a true response that confirms the database name begins with an S. So we're going to try that quickly. And we have username from here, paste that, hit enter, and we get a true. Now you move on to the next character. It would be a try and error thing of, so continue to try and you would find another true response, for example SA, SB, SC with the percentage sign, etc. Now this keep on this process until you discover all the characters database name, which is SQL3. So that's SQL3. Now we've established the database name, which we can now use to enumerate tables name using a similar method by utilizing the information schema database. Now try setting the usernames to the following value: admin 123 union select 123 from information schema table, where table schema SQL3 and table name like A. Now in this case we now have the database name. We want to now enumerate and look for the table name, okay, which we in this case we want to try to see if it starts with an A. All right, now the query looks like the results. The query looks for the result in the information schema database in the tables table, where the database name matches SQL3, and then the table name begins with the letter A, as the above query results in a false response. Now we can confirm that there are no tables in the SQLi 3 tables that begins with the letter A. Like previously, you will need to cycle through letters, numbers, and characters until you find a positive match. It's tedious. Now you finally end up discovering a table in the SQLi 3 database named users, which you can confirm by running the following username payload. Let's do this. So we finally see that as users. That should give us true. Now no need to do that. Let's continue. Lastly, we now need to enumerate the column names in the users table, same pattern, so we can properly search it for login credentials. Again, we can use the information schema database and the information we have already gained to query it for column names. Using the payload below, we search the columns table, where the database is equals to SQL3, the table name is users, and the column name begins with an A. We'll try that as well. Then again, you will need to cycle through letters, numbers, and characters until you find a match. As you're looking for multiple results, you will have to add this to your payload each time you find a new column name to avoid discovering the same one. For example, once you found the column name ID, you will now append that to your original payload as seen below. Since you're looking for, we have a table name equals to users and column like A, because you're now looking for more columns, and column name not equals to ID, so that if it won't it won't include ID, so we're looking for new ones. Now repeating this process 3 times will enable you discover the column names, ID, username, and password, which now can be used to query the user table for login credentials. First, you will need to discover a valid username, which you can use for the payload below. So we'll now start again by using the admin 123 union select 123 from users where username is like this. So we finished getting the column names, and now we're looking for usernames. Alright, once you've cycled through all the characters, you confirm the existence of the username admin. Now you get the username, you can concentrate on discovering the password. The payload below shows you how the password should go. So more or less, username is admin and password like A, and you start to rotate. Just note that it has both letters, numbers, and so on, so it can be tedious. Now cycling through all the characters, you discover the password is 3845. You can now use the username and password you've enumerated through the blind SQL injection vulnerability on the login form to access the next level. Because of time, I'm unable to just do this because I can't do that and be recording, so we just use the example. And then we have 3845, hit enter, login, and that was successful. And we can see that because we get to level 4, and this is our flag. So paste that flag here and hit submit. Correct. Let's head on to task 6. Okay, task 6 here is a time-based. Okay, a time-based blind SQL injection is very similar to the above Boolean-based one in that the same request are sent, but there's no visual indicator of your queries being wrong or right this time. So instead, your indicator of correct query is based on the time the query takes to complete. Now the time delay is introduced using built-in methods such as sleepx alongside the union statement. The sleep method will only get executed upon a successful union select statement. Now, for example, when trying to establish the number of columns in a table, you would see the following queries: admin 123 union select sleep 5, and then this query ends, and then a comment dash dash. If there was no pause in the response time, we know that the query was unsuccessful. So like on previous tasks, we add another column. So if we copy this right here, and let's come over here where we say referral equals to Tryhackme, we remove that and hit paste this and hit enter. You see there was no pause in the response time, so we should know that this was particularly unsuccessful. Now we're going to this payload, the above payload where we have 5,2 should produce a 5-second delay confirming the successful execution of a union statement and that there are 2 columns. So if I copy this, Ctrl C, and come over here and paste that, hit enter, and we're getting a delay, and boom, we get a result. So okay, so you can now repeat the enumeration process from the Boolean based SQL injection, adding the sleep method to the union select statement. If you're struggling to find the table name, the below query should help you on your way. So referral equals to admin 123 union select 5 sleep where database is like this, and so on and so forth. What is the flag from completing level 4? Now due to time, I cannot be able to do this on the video, but I'm able to find out that the username is admin and the password is 4961. Hit go into login here, and voila, training complete, and we get our flag here. Okay, for completing level 4, we hit submit, and that is it. So I think we're done, so I can close this. Right, let me minimize this. Okay, let's quickly get out to task 9, out of band SQLi. Out of band SQLi injection isn't as common, as it either depends on specific feature being enabled on the database server or the web application business logic, which makes some kind of external network call based on the results from the SQLi from an SQL query. An out of band attack is classified by having two different communication channels, one to launch the attack and the other to gather the results. For example, the attack channel could be a web request, and the data gathering channel could be monitoring HTTP/DNS request made to the service you control. Now, number one, an attacker makes a request to a website vulnerable to SQL injection with an injection payload. Now, the website makes an SQL query to the database, which also passes the hacker's payload. Now, the payload contains a request which forces a HTTP request or DNS back to the hacker's machine containing data from the database. So that cycle, hacker to the website, passing that particular SQL query to the database, which in turn returns the request, forcing a HTTP request back to the hacker. Now, answer the question below. Name a protocol beginning with D that can be used to exfiltrate data from the database. That should be DNS. Domain name system. Okay. Last is task 10, remediation. As impactful as SQL injection vulnerabilities are, developers do have a way to protect their web applications from them by following the advice below. One is to use prepared statements with parameterized queries. Okay, in a prepared query, the first thing a developer writes is the SQL query, and then any user inputs are added as parameters afterwards. Now, writing prepared statements ensures the SQL code structure doesn't change, and the database can distinguish between query and the data. As a benefit, it also makes your code look much cleaner and easier to read. Second is input validation. Input validation can go a long way to protect what gets into an SQL query. Employing an allow list can restrict input to only certain strings, or a string replacement method in the programming language can filter the characters you wish to allow or disallow. Lastly, here is escaping user input. Allowing user input containing characters such as the apostrophe, the quotation mark, the $, the backward slash can cause SQL query to break, or even worse, as we've learned, open them up for injection attacks. Now, escaping user input is the method of prepending a backslash to these characters, which then causes them to be passed just as a regular string and not a special character. Name a method of protecting yourself from an SQL injection exploit. Hint starts with P, that should be prepared statements. Copy that, paste, hit submit. Congratulations, this is the end of the room SQL injection. Thank you for studying with me, thank you for learning with me, and this is the end of this particular module, which is introduction to web hacking. We just completed the SQL injection. Thank you for studying with me. I'll see you guys in the next video. Enjoy. Ciao.